This is for Year 12 specialists. It comes out of 8E, lengths of curves in the plane. And I've picked up from the textbook the two formulas for working out the length of curve. Question 3 is I do not use the calculator. And by the looks of it, because they've told you to find the derivative and then hence, this must be integration by recognition. So let's take the derivative first. So I know that f of x equals log base e of sec x plus tan x, and that is the derivative of the chain rule because I've got the logarithm of something. So its derivative, f dash of x, will equal 1 on sec of x plus tan of x, then the derivative of the inside, and sec of x equals 1 on cos of x. Therefore, that's equal to cos of x to the power of -1. So its derivative will equal -1, so d dx of sec x times cos of x to the -2 times negative sine of x. It's going to be positive sine of x on top of cos of x squared. So that will be sine of x on cos of x squared plus the derivative of tan, which is sec squared of x. I've got 1 on top of, I might give myself a little bit more room, I have 1 on top of 1 on cos of x plus tan of x, which is sine of x on cos of x, which is 1 on 1 plus sine of x on top of cos of x, which is cos of x on top of 1 plus sine of x. And that's being multiplied by sine of x on cos squared of x plus 1 on cos squared of x, which is the same as 1 plus a sine of x on top of the cos of x squared, which is 1 plus a sine of x on top of the cos of x squared, and they cancel. And what do those cancel? To leave 1 on the cos of x. So the derivative of this will equal 1 on the cos of x. This will equal 1 on cos of x. Hence, log base e of sec of x plus tan of x must equal the integral of 1 on cos of x dx. So the length of the curve L with the integral from 0 to pi on 4 of the square root of 1 plus the derivative of this and the derivative of that, the derivative of log base e of cos of x. So if y equaled log base e of the cos of x, its derivative will be 1 on the cos of x times negative sine of x, which is negative tan of x. 1 plus negative tan of x squared, which will equal the integral from 0 to pi on 4 of the square root of 1 plus tan squared of x, and 1 plus tan squared of x is equal to the integral from 0 to pi on 4 of the square root of sec squared of x, and that's going to be the integral of 0 to pi on 4 of sec of x dx, which is equal to the integral from 0 to pi on 4 of 1 on cos of x dx. And I know from part A that the integral of 1 on cos of x dx is equal to this. It's going to equal log base e of sec of x plus tan of x from 0 to pi on 4 which will equal log base e of 1 on the cos of pi on 4 plus the tan of pi on 4, which will equal log base e of 1 on root 2, so root 2 plus 1 cubic units.